Welcome to Math Challenge 456. Math Challenge for all quantitative and numerical aptitude tests. In Math Challenge 456, we are given a quadrant, a vertical line 8 units in length, and it cuts the radius, part of which is shown as 4 units, and we have to find the radius of the quadrant. You can see the figure, a quadrant and a line uh, intersecting with the radius. The segment lengths are marked, and we have to find the length of the radius. Math challenge 456. Now we will show you not one method but two methods. There are two methods by which we can solve it. We will show you two methods. So let us see the first method of finding the radius of the quadrant. Now from the center O, join the radius as shown. You can see the animation. You can see the animation. From the center O, we join the radius. It will meet the vertical line at the circumference of the quadrant. So from O, we draw the radius as shown. You can see the animation. So this radius meets the top of the line segment marked 8 units at the circumference of the quadrant. Now look at the blinking right angle triangle. The blinking right angle triangle, the hypotenuse is the radius r, the base is 4, and the altitude is 8. Look at the blinking triangle, the right angle triangle, where hypotenuse r, base 4, and altitude 8. So by Pythagoras theorem, r square equal to 4 square plus 8 square, that is r square equal to 80, r radius equal to square root of 80, which is 4 root 5 units. From the blinking right angle triangle, by Pythagoras theorem, r square is equal to 4 square plus 8 square, that is r square is equal to 80, r equal to square root of 80, that gives 4 root 5 units. That is the value of the length of the radius of the quadrant. Now, although the first method was very easy, but we have a second method. We told you we will solve it by two methods. So here is the second method, which does not require application of the Pythagoras theorem, but the properties of a circle, the chords of a circle. Now, quadrant is quarter of a circle. So we complete the circle. We complete this circle. Quadrant is only a quarter circle. So we complete the circle as shown by the red dotted line. So we get the full circle. The quadrant we expand into a full circle with center O. Now extend this vertical line. Extend this vertical line. Obviously, this horizontal line, if you extend, it will be the diameter. So extend the horizontal line to form the diameter and extend the vertical line. You will get the chord. Now, if the top is 8, the bottom must be 8. The vertical line, the upper part is 8, so the lower part should also be 8. Now, from center O, this part is 4 units. So the total is the radius r. So this part will be r minus 4 and this part will be r plus 4. From O to the circumference, it is r. So the longer length of the chord, the horizontal chord will be r plus 4 and the shorter length of the chord will be r minus 4. So the shorter segment of the chord r minus 4, longer segment of the chord r plus 4, and the vertical chord will be 8 and 8. Both will be 8. So extend the horizontal and vertical chords. The vertical chord is 8 plus 8. The upper part 8 and the lower part 8. And the horizontal chord, the shorter segment r minus 4 and the longer segment r plus 4. Now we apply the property of intersecting chords. When two chords intersect, the product of the segments should be equal. So r minus 4 multiplied by r plus 4 is equal to 8 into 8. R minus 4 into r plus 4 equal to 8 into 8. That is r square minus 16 equal to 64. Minus 16 we transpose to the other side. So r square equal to 80. R equal to square root of 80. That is 4 root 5. Then applying the property of two intersecting chords in a circle. R plus 4 and R minus 4 are the two segments of the horizontal chord, and 8 and 8 are the two segments of the vertical chord. So R plus 4 into R minus 4 is 8 into 8. R square minus 16 is 64. R square 80 and R square root of 80, 4 root 5. This is the same answer as we got before. The second method, using the intersecting chord property of the circle instead of the Pythagoras theorem. So the value of r, the radius, calculated in either of the methods would be 4 root 5 units.
Was that interesting? If you have any other method, we would love to learn from you. We shall come back with more interesting videos. Like, share the videos, and subscribe to our channel if you are a math lover. Till then, goodbye.